All right, our first video in this unit is going to be on segments. It's also the first video of the year here, so to get you guys used to it, I'm going to go over everything that you're going to see in each of the videos going forward. So the most important thing to pay attention to at the top of the page is going to be the success criteria. So these are the three things that you're going to want to be able to do by the end of this video. It's also where the practice section after the video is going to focus on. These are the three key things that we're working on. We want to be able to identify and define the different parts of a segment. We want to be able to set up an equation using segment addition and subtraction, and then solve for the length of the segment or any missing variable that we're going to get as we go through. So I have some vocabulary words put out. I typed it out for you so it's a little easier to read, and I'm going to go over each one. So the first vocabulary word is a point. All right, it's a physical location in space. It's represented by a small filled-in circle and a capital letter. So normally what you'll see somewhere on the paper is you'll see a dot like this, and it's usually given a capital letter A, B, it could be any letter, but this is how we label our points. All right. Second vocabulary word is straight lines. So lines are continuous in both directions. So it's a continuous collection of points that extends forever in two directions. And for purposes in geometry, all lines are going to be straight lines. We're not really going to deal with too many curves until we get to circles. But what happens is we have a line that continues in both directions. And on this line, there are an infinite amount of points. Okay, and usually the way you'll see it labeled in a question is it will be labeled with two letters. So for example, this being line AB, we will label it as AB with an arrow on both ends. That's what you would see in the question or anywhere that you need to reference where this line is. The third one is the line segment. That's going to be the most important one of this video. A lot of what we're going to see is finding the lengths of these line segments, is finding how long they are, setting up equations for these line segments. So this is also going to be a collection of points. There are more than just two. In a given line, between 2 points on the line, they do not extend forever in either direction. So what a line segment is going to happen is it's going to have 2 points at the end. That's really how you determine where your line segment is. So for example, we could say this one is XY, and this is our line segment. It starts at X and ends at Y. But again, because points can kind of be anywhere, there are an infinite number of points. And as you'll see later in the questions, sometimes we have multiple line segments in one picture or in one question. So the way we label these is going to be the same thing with the two capital letters as we did here, but instead of having arrows on top, it is just going to be a bar across the top. You're going to see this one a lot. This is very, very important. You're going to see this all year. Line segments are going to be what make up our different shapes, our triangles, our parallelograms, our rectangles when we get to them. So we really, really have to get comfortable with line segments. All right, the last vocabulary word that we need is collinear. This is when 3 or more points lie on the same line. So in these two things that I have drawn up here, all of these points would be collinear since they all are on this same line. All of these points would be collinear. They would all be on the same line. There's no real picture for this. They're kind of right here, but it's just anytime you have 3 or more points on one line segment, one line, it doesn't really matter which vocabulary word you use there. So how do we use this? What are the questions going to look like? I have 3 examples for us to go through together. So we'll go through the first one here. First example says, in a diagram below, DEF is shown. Now with this, you see this little line up here. So we got DEF and there's a line. That means that these 3 points are on the same line. So this is one straight line. There's no curves, there's no bends. And D to F is the longest section of this line. There are line segments here. All right, we have these points must be collinear because they are labeled together. Again, all 3 letters underneath the bar means it is one line. Now they give us these measurements. So it says D to E is 5x plus 2. So the way that I would label that is D to E is 5x plus 2. So that's going to go here. This is how I would write this. All right, E to F is x plus 7, so I would put the x plus 7 here, and now D to F is 33. There's a couple different ways that you can label D to F. When the pictures get a little bit more complicated, we'll go over some different strategies. But for right now, the way that I'm the most comfortable is I would draw kind of like this squiggle here to show that this entire line segment measures out to 33. And the question says that we are going to solve for the value of x. So what do we know about this line segment? Well, we know d to f is the longest part. So what we're kind of learning here, what we need to know is that d to e plus e to f makes up 33. I jumped into a little bit of a more complicated problem to start with the algebra, but the way you're going to want to look at this, if we write it in notation first, we can say the segment of d to e plus the segment of e to f is equal to d to f. And now we can just plug in what each of the values are. So we know that d to e is 5x plus 2. We know that e to f is x plus 7. And we know that d to f is 33. And then we would solve this using kind of our algebra skills that we've been going over in class. I'll try to zoom in to make it a little bit easier. I would draw my line down the equal sign. We're going to combine like terms on this left side. So we got 5x and 1x, which is going to make 6x. We have 2 and 7, which is going to make 9. Now we have nothing left to combine on this side. So we'll subtract 9 from both sides. And we will get 6x equals 24. And then our last step, we'll divide by 6. And we get x equals 4 as our final answer. Now, if we wanted to find the length of the two smaller segments, we could plug x back in. We're going to see that a little later, so we're just going to leave this off at the end. The question asks for x. We have x, and that's it for this question. So key things when going through this, make sure you label your information. It will make the equations a little bit easier. It will make it a little bit more intuitive for you. There's no real formula to memorize for any of this. It's kind of looking at the picture, placing your information on the picture, and then setting up a necessary equation. Now, moving on to example 2. This one doesn't have any algebra in it. Hopefully it's a little bit easier. So again, we have e to g is 20, f to g is 17. What is the length of e to f? So again, I would go back and label e to g is 20. In this case, it's going to be this whole piece here is 20. F to g is 17. It's going to be this side here. And then what is the length of e to f? So now, what you can do, a little strategy that we use sometimes, is I can put an x where e to f is. And then from here, I can kind of set up my equation. It might make things easier for you. Some of you probably already know the answer, but if you're still having a little trouble, again, these two smaller segments here, right, are going to add up to the whole segment. So we're going to have x plus 17 equals 20. And then again, our algebra, subtract 17, and we get x equals 3. Right? And that's really it for example 2. All right, like I said, take your time, label the information. Don't try to just jump right to the equation. Putting things on the questions is extremely helpful. All right, last question. A little bit more on this one. In the following diagram, if AB is 3x plus 8, BC is x plus 2, and AC is 22, what are the lengths of the two sides? So it's not really asking us to solve for x in this question, but we need the value of x in order to find the lengths of those sides. So again, I'm going to go through and label first. It's always kind of my first step. If AB is 3x plus 8, we're going to put 3x plus 8 in here. We have BC is x plus 2. We're going to put that in here. And again, AC is 22. So this whole thing makes 22. Now, from here, I can kind of see where my equation is going to be set up. I know I have my two smaller pieces are going to add up to the whole thing. So I can set up our equation from here. We have 3x plus 8 plus x plus 2 equals 22. Again, I would put my line down the equal sign for my algebra skills here. Probably make life a little easier for you. So we got 3x plus x is 4x, 8 plus 2 is 10. Now we have nothing left to combine, so we're going to move things to the other side. Subtract 10 from both sides. We got 4x equals 12, and then we have x equals 3. Now, unfortunately, this is not our final answer. You do have to pay attention in geometry to what the question is actually asking you for. The question does not say solve for x. It does say solve for the lengths of the two sides. So we are looking for a to b, and we are looking for b to c. So what we're going to do for that is we are going to take our AB, that is 3x plus 8. And now since we know what x is, we can plug that in. 3 times 3 plus 8. And AB is going to be, 3 times 3 is 9, plus 8 is 17. So we know that A to B is going to be 17. You don't really have to plug in for BC. Some people might see we can just kind of do 22 minus 17. If you'd like, you can plug it in. If you want to double check your work and check your answer, you can. If we do the same thing here for BC, we would say x plus 2. We know that x is 3, so it's going to be 3 plus 2, which is 5. And again, to double check your work, hopefully 17 plus 5 should be 22. So that should all work out. So that's going to be our third and final example for segments. Again, going back up to the success criteria from before, make sure if you need to watch this video again, you really focus on these three things. Can you identify the different parts of the segment? Can you set up the equation? And then at the end, can you solve? Those are kind of our three big keys as we go through this video. You'll see the little stop sign on the bottom. All right, make sure that you move on to your other packet. You complete the practice questions. All right, once you finish those practice questions, you'll take your short 5-question mastery check, and then you can move on to video 2. I'll see you guys there.